Hello everyone, in this video we will be solving problem 104, maximum depth of a binary tree. The problem statement is, given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node. In example number 1, the longest path is from 3 to 20, either to 15 or to 7, because in both the cases the depth is 3. For example number 2, its equivalent binary tree representation would be 1 at the root, nothing on the left because it is null, and 2 on the right. So its depth is 2. The couple of constraints that are given to us are the total number of nodes in the tree is in the range of 0 to 10 raised to power 4, and the value could be from negative 100 to positive 100. This is a very easy problem, but it is very important to understand how can you iterate through a binary tree efficiently to solve other complex problems in LeetCode. Now let's switch to whiteboard and discuss the solution. There are two ways to traverse through a binary tree. One is DFS and other is BFS. DFS stands for depth first search and BFS stands for breadth first search. As the name suggests, for DFS, we go to the very last leg of a binary tree and start processing that node, versus on the breadth first search, we process all the nodes at the same level. Considering the problem statement is asking us to figure out the maximum depth of the binary tree, we should use the BFS approach as it will be a bit more efficient. Again, we could use a DFS approach as well, which will give us the same results in terms of time complexity. BFS sounds more appropriate here. When solving the problem, we'll use a max depth variable which will hold the maximum depth that we have calculated so far, and we'll start off with setting this value as 0. When we start the iteration at node 1, its depth would be 1, and we'll compare this against the maximum depth and save whatever is higher into the variable. So considering 1 is higher, so we'll replace 0 with 1. We'll now look at the child nodes or left and right legs of node 1. So with 2 and 3, both are at the same level. Its depth is 2. Is it higher than the current one? Yes. So we'll replace the maximum depth to 2 and continue the traversal. I don't have any legs on node 2. So we'll stop the iteration here and we'll look at 3. 3 have 4 and 5. Both are at the same level or depth. So my D will be 3. I will save it in the max depth because it is larger, it is higher than the current value. As there are no more nodes after 4 and 5, so we'll stop the iteration here and return these results. The time complexity of this solution is O of n, where n is the number of nodes in the binary tree, and space complexity is O of 1. I hope you were able to understand this simple explanation. Let me show you how we can implement this using C#. Here is my solution. I have created this helper method called check, which accepts a tree node, a current level or depth, and the maximum level that we have calculated so far. Whenever we encounter a null node, I compare the current level that have been passed into this method against the max level and returning the higher value. If node is not null, I am calling the method iteratively again, passing the left node, incrementing the current level by 1 and the maximum level that we have calculated so far. And whatever this check method will return, I am saving it in the max level variable. I am doing the same step but with right node on the next line. After both these operations are complete, I am returning the max level back. And in the main method, I call the check method by passing the root of the tree node, the current depth being 0 and the maximum depth as 0 as well. And after this iteration is complete, I will have the maximum depth in this variable and returning it in the next line. If you look at the analysis, this solution beats 100% of the submissions made to LeetCode so far in terms of time complexity and beats almost 49% in terms of memory utilization. Thank you for watching this video. I hope you were able to understand my approach and the solution. If you have any questions, feel free to reach out to me. The link to the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.